So this is session 2 of the map practice test, and the front of it looks like this, the release practice form. I'm just going to go through how to do session 2, just so that you can see how I would approach the problem. Now, you're going to see a lot of times I'm going to say pause yours, try the problem on your own, and I really would like you to do that, pause it. And if you're going, I don't have a clue, then you just unpause your video and you watch, okay? So I'm going to go through how to do the different problems, all the problems on session 2. So here we go. Let's start with number 1, though. Number 1, you can read it on your own. I don't need to read it to you. And again, I recommend that you pause yours, read the problem, see if you can do it on your own first and figure it out. So on this one, what you want to look for on all your testing is look for keywords. See how this one says 1/3 of? Whenever I have 1/3 of or 1/2 of or anything, that means I'm going to take 1/3 times. And what am I going to take 1/3 of? The paycheck. So I'm going to take 1/3 of the paycheck. 1/3 of the paycheck. We don't know what that is. That's what we're trying to find out. So I'm going to have 1/3 X. But it tells us that he has 75. Okay? And see, if I write it out first, then I just come over here and I can find my answer. Good. Let's do the same thing on number 2. Pause yours. Find the answer first. So what we're doing on this one is it gives us a chart, and then it says, what does this ordered pair mean? So when you look at ordered pairs, remember your ordered pairs always go alphabetical order, X and Y. So 5 is the X coordinate. Well, what is the X coordinate standing for? Time. So 5 minutes, okay? And then on the Y-axis, 25. What does 25 stand for? How much is charged? Then it's going to have a 25% charge. Okay? So 5 minutes, charge 25 tablets. Nope. It's a 25%. So see how it's going to be C. Number 3. Now, hopefully you can solve this one on your own. Come right over here. Solve that inequality. This is what we did on the quiz. Okay? We've been doing those. Solve that inequality. Pause and do it. Oops. Sorry, switch to another thing. Didn't mean to do that. Okay, so to solve this one, I'm going to subtract 12 from both sides. I'm going to divide by a -2. Pause. Divide by a negative. What's going to happen? That's right. That inequality sign is going to go the opposite direction. So X is greater than -3. Find that right here. Okay. Number 4. Write an expression is shown. Which expression is equivalent to the given expression? Now, we have talked about this briefly, and you've probably done an IXL on this. Remember, I'm going to use distributive properties. So I'm going to take -3 times X and -3 times 4. So -3 times X, -3 times a -4. This is seen as a negative, okay? Remember, your brain has to be able to see that's a minus, but it's also a -4. So that's plus 12. Find the one that matches. Yay. Okay, number 5 was the one that caught me off guard. So I had to draw a picture. I had to do lots of different things with it. Linda ate 1/8 of the batch of cornbread. Peter ate some cornbread. Some. We don't know how much. So now there is 2/3 left after he is done. What is remaining? Write a fraction of the batch of cornbread that Peter ate. Okay, so draw a picture first. I think it's easier. If you want to, again, always pause or try it first. So what I did is I said, okay, Linda ate 1/8. I don't know how big this is. I'm just making it up, okay? I'm going to make that a little bigger so you can see what I did there. So here is 1/8. So she ate 1/8 of it. And then when Peter was done, 2/3 of it was left. Okay? So that just kind of gives you, here's 1/3, here's 1/3, and here's 1/3. Okay, so that just kind of gives you a visual picture. He ate some. We don't know how much, but there's 2/3 of it left. So he ate approximately like this stuff right over here, we'll say. Okay? Maybe they didn't eat off the same quarter, but you get the idea. So then what I did is I said, okay, what is left after Linda is done? Well, we start off with the whole thing, which is 1. We always start with 1, which is the whole thing, and we subtract off 1/3. So, oops, 1/8. My fault. Linda ate 1/8, not 1/3. So if I take 1 minus 1/8, okay, one option, do it with a calculator. Another one, you can just kind of use common sense if I take 1/8 away from 1. The other one is, remember, I can always change it so it has a common denominator. I want the denominator of 8, so I choose that. 1 is 8 over 8. So I get 7/8 left. So now what we have to realize is that's what is left is 7/8. We're going to subtract off some to get what Peter ate. But couldn't I also say, couldn't I take off what is left, which is 2/3, and get what Peter ate? Whoops. So I can write it this way. This is Peter, and we have 2/3 left. But I could also just take what I have, subtract off what's left after Peter, and get it. Again, your calculator can do that for you. But even better is let's get a common denominator. The easiest one is 24. 8 goes into 24 3 times, so I multiply by 3. 7 times 3 is 21. 3 goes into 24, 8. So 2 times 8 is 16. Remember, when you subtract fractions, you only subtract the numerators. Denominator stays the same. 21 minus 16 is 5. There we go. Okay, good. That was one I had to think about for a little bit too. Number 6. This should look familiar. Look at that. When something is proportional, what are we looking for? That's right, the constant of proportionality. Okay, definitely pause yours and figure that one out. You know that. Okay, if you forgot, I'll tell you in just a bit. Pause it, go find it, go. Okay, remember, constant of proportionality is y over x. And you can take any value that you want, any y value that you want to, and we can find the constant of proportionality using our calculator. So I'm just going to choose 0.9 divided by 2 because it's y over x. So I take 0.9 divided by 2, and we get 0.45. That's our constant of proportionality. Okay? Number 7, read that one. Now this one should sound familiar too, because when we were doing word problems with inequalities, we were talking about this all the time. But this time, it's going to be an equation. It costs $32. He already has 18, saves the same amount of money each week for 4 weeks. How much money in dollars will Jorge have to save to get exactly? So that means it's going to be equal to 32. Okay, so what is his money that he has? He has $18. Plus, he's going to save the same amount, X. That's what we're finding. Okay, X is the amount of money that he wants to save. That's your equation. Okay, now we just solve that equation. Go ahead and do that. Pause yours, solve it. We're going to subtract 18. We're going to divide by 4. When we divide by 4, we get x is equal to 3.5. Now, that is not our answer, though, because they are asking for money. When they're asking for money, we need to give our answer in money. So $3.50. Now, if this is a computer one, they'll probably have the dollar sign out here, hopefully. So just to let you know, you don't always have to put the dollar sign in. Number 8, read through that one. Okay, now that you've read it, let's talk about theoretical and experimental. There are 2 different types. These are one of the 2 different types of probability. So let's talk about what they are. That's going to make a huge difference. If I talk about theoretical, the root word is theory. Theory. A theory is just an idea someone has. Okay. Now, a lot of times those theories are supported. But that's a theory that someone has. So this is an idea of what might happen. Theoretically, this could happen. So this is an idea. Experiment. Look at that root word. Experimental is experiment. You actually do something. So if I'm talking about theoretical, I'm talking about the idea of it happening. And when I'm talking about coins, okay, if I'm talking about coins, I have a heads and a tail. So the theoretical probability, I have one heads or tails, it doesn't matter, out of 2 different choices. And remember, probability is always total over what they're asking for. That's probability, remember. So I have a total of 2 heads and a tails. And if I want heads, 1, tails, 1. Okay, so it's a 50% chance that I'm going to get it. Now, Lily did trials. That means she did experimental probability. So if I look at experimental probability, she had 20 trials. She did 12 of them. So then I would find that percent, and they tell us that that's 60%. So if I'm talking about experimental, I have to use 60%. Theoretical has to be 50%. Okay, so just to let you know that if theoretical and experimental come up, remember, idea. So look at this. The theoretical probability is 50%. That is correct. But the reason behind it is not because at least 50% of Lily's coin tosses landed with the tails up. See how now they're going into experimental. That's the trick question. That one's almost mean because they're saying, yeah, it's 50%, which is correct. But then they say that she tosses. So that one cannot work because she's actually doing something. She's doing experimental probability. So we're not talking about theoretical. The theoretical probability, again, the idea, has to be 50% with coins. And they talk about 60%. Can't be that. And also, she did an experiment, so it can't be theoretical probability. Experimental probability is 50% because at least 50% of her, no, okay, experimental probability, she did, that one can't work. Experimental probability with landing with the tail side up is 12 out of 20 because that is what Lily observed. So experimental, do something. You have to observe it. Theoretical, just think about it in your head. You're doing nothing, okay? Good. Number 9, look at that one. Pause it if you want to. What you're using here is we have a line, these two angles. And a line is also called a straight angle. A straight angle. Well, look at that. How many degrees does it go from here to there? Right, that's 180. So 180 degrees is what that straight angle is equal to. So if A is 38, how am I going to find B? That's right. You're going to take 180 minus 38. And that's where we get 142. Okay? Number 10. Oh, definitely pause. You can do this one. You should be able to do this one. So pause yours. Try this one. Okay. Luis went to a movie with $20. The tickets cost $9.50. And he spent $2.75. So he spent $9.50. And he spent $2.75. So he has spent $12.25. Hopefully I did that right. Now he has $20, so I take 20 minus $12.25, subtract, and of course you're going to get a $7.75. Number 11, yes, we could go through mathematical, and I will do that, but we can also just kind of look at this. Hopefully you've read it. If not, pause and read it. So we have 3 identical stacks of coins. And we have a percent error of 3%. The scale says the weight of the first stack is 10. That's a definite. Scale says the second one is 10.3. Okay, that's a definite. Round to the nearest tenth of an ounce, what is the greatest possible amount? So greatest possible amount between these 3 coins. Okay, this one's already going up, so this has to be my lowest value. This so far is the highest, but could I also go one higher? So could I take and multiply by, so I'm going to take my highest one. Mathematically, this is what I would do, 10.3 times 3%. Remember, 3% is going to be changed to a decimal. When I multiply that, I get 0.309. So I'm going to take 10.3, and I'm going to add, round to the nearest tenth, 0.3. I get 10.6. But couldn't you also kind of see, because look at the options. It's not going to go down if it's the greatest. That one's out, that one's out. Even that one's out, because that we already have. So the greatest, it could be higher than that one. You didn't have to do all that math, people. Just kind of look at them sometimes, too. It doesn't hurt to do the math, though. Okay, read this next one. If you haven't already, pause it. We'll keep going. Okay, so I made some notes to myself because I think it's easier when I have that much information to kind of collect my thoughts down here. And I would highly recommend that for you, especially while you're taking the test. Make some notes and you'll have plenty of scratch paper in order to do that. So we know that the mean of class X is 4.2 as far as number of books that the class read. So this is a class out of 20 total students. The average is 44.2. Okay, so now let's read through our options and start eliminating ones that we know don't work. Every student in class X read more books than every student in class Y. Whenever they say every, that's kind of a big clue that it's probably not going to be that, because that is really exact. And we're talking about mean. We're talking about what is the average number of books out of it that everybody read. So that one's going to get eliminated. Because also the average, if the average, okay, look at that, even though this one's higher, there's a person in this class that could have read 7 books and somebody else who could have read 1. So that average is going to bring it back down. Okay, so that one's out. The students in class X like to read more than students in class Y. I can't say anything about whether they like it or not, because these are just numbers. We can't use that one. The students in X read longer. Okay, is this talking about how long they read the books? Or what size the books were, or just the number of books? Notice it just says number of books. So that one's out. Wait, and in 2 statements. We have to pick 2 statements. Yay, we're done. We don't even have to read the other 2. We know that it has to be these, but we always want to double check just in case we mess up on one of these. On average, the students in class X read more books than in class Y. On average, exactly what that number says. E, the total number of books read by X is more than the total number of books read by Y. Right. So if this number is higher on the average, that means they actually had to read more books in order to have a higher average. So yeah, D and E work. Nice. Okay, question 13. Ella designs a class tabletop for, oh, you can read on your own. Pause it, read this one, try it, go. Okay, the important ones here is it says that each one of these grids is 12 inches. So this is 12 inches. But what happens with the new drawing is that each square in the new drawing is only 6 inches. 6 inches in the new drawing. So if I have 1 square up here, it's going to be the same amount of how many down here. If this is 12 up here, but each of these is only 6, think about that. I'm going to have to do 2 squares for each one up here. So what we do is we look to see how long is this. That's 1, 2, 3, 4, 5, 6 long. So if it's 6 long up here, how many is it going to be long down here? 12, exactly, because I have to double it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's the bottom. Now I'm going to do that on all of them. 1, 2, 3, 4. So what does it have to be down here? That's right, 8. Here's that one. And this one, you can count and do that one on your own. So 6 up here, 12 down here. Now, what we do is we don't count that other one because we can't. We don't have the ability right now to do that, okay? There's our drawing. Good. But use that knowledge. Pay attention to what's going on. Okay? Chelsea buys a bag of apples. In the bag, there's 8 11ths. What number could this be as far as a decimal? You have a calculator, people. Use it. So use your calculator. 8 divided by 11. I get 0.72727272. Triangle has sides of 4, 6, and m units. The geometry teacher in me comes out. I'm going to draw a triangle, 4 and 6 and m units. We don't know what that is. Select the 2 numbers that are possible for values. Here's the thing you need to know on this one. And this is a geometry concept that you'll learn. You probably already learned it once, but if you were like me, I forgot it. So I looked it up. And here's the concept you need. The sum of 2 sides of a triangle. Sum, remember sum means that I'm going to add them together. What's the answer after I add? Is greater than, so bigger than, the third side. Okay? So what we can do is we can take each one of them. So I can take 4 plus 1. Is that greater than 6? Nope, that doesn't work. What if I take 2 plus 4? Is that greater than 6? No, it's equal to, but notice it has to be greater than. It can't be greater than or equal to. So that one doesn't work. Okay, let's try 5. 4 plus 5, is that greater than 6? Yes. Okay, keep going with 5. Let's see. 4 plus 6, is that greater than 5? Yes. And 6 plus 5, is that greater than 4? Yes, that one works. Here we go. 4 plus 8, greater than 6? Yep. 4 plus 6, greater than 8? Yes, that's 10. 6 plus 8, greater than 4? Yes. And we only need 2, so we know that's our answer. Some of you might be going, but doesn't 12, well, at first it does. 4 plus 12 is greater than 6. But is 4 plus 6 greater than 12? Nope, that's the reason it doesn't work. Okay, number 16. Sophia earned $18 for working 2.5 hours, 2 1/4 hours. How much did she earn per hour? Try it. Okay, so what we're doing per hour, we're taking money divided by hours. Okay, or we could have made a table of money and hours. Whoops, I did that wrong. Okay, we could have put in money and hours. Okay, and found it. This is also just like unit price. Unit price is always price over the number of units. So our price is $18, our units are hours. So when you divide there, of course, you get 8. Okay, read 17, pause. Now this one looks like it's confusing at first, but what we got to concentrate on is right here. They give us the expression, x minus 0.03x. And remember, if I ever have a variable that doesn't have a number visible, that means that there's actually a 1. So this is 1x minus 0.03x. That's what this is saying. That's the same thing. Now, what this basically does, best explains how to simplify, is this is asking you if you know about like terms. And we talked about like terms back when we were in first session. If you treat like terms like inches, so pretend like this is 1 inch minus 0.03 inches. Okay? If I'm going to subtract that, when I subtract, I take 1 minus 0.03, and I'm going to get 0.07 inches. So my variables didn't change. Okay? So keep that in mind. So for A, combine x and 0.03x since they are like terms, cancel out the x. No, did we cancel out the inches? No, we still have to pay attention to them, so that doesn't work. Combined x and this one, since they are like terms, subtracting to find the new coefficient. That's what we did. We found the new coefficient. That one works. Oh, we only need 1. Hey, and these two get eliminated because factoring. Now, here's a disadvantage. We might not actually get to factoring before you take the map test. So just to let you know, this means when you take it out, you want to combine. Those two don't work. 18, the graph shows the number of hours. Oh, this is number one of those ordered pairs. Try this one on your own. Look at this. Remember, it's x and y. X, then y. Go, try it. So what I did is I look at the ordered pair and I match it up. 3 is the x value. So 3 is items assembled. 6 is the hours. So I wrote 3 items, 6 hours. I write that down first. Now I go look at it. It says 3 hours. Nope, we're talking about 6 hours. So those two are out. 6 hours to assemble 1 item. Well, we assembled 3, so 6 hours to assemble 3. But if I write this down too, take the ordered pair, write out what it means, it sure does make my life a whole lot easier. Okay? Oh, this one's just plain fun. We get to fill all these in. Now, we're supposed to fill it in with these numbers, and that's where I messed up. So what I did is I just went through and I filled it in, and then I'm going to go back and put the numbers in because that's confusing. So notice my options are small, medium, large. So small, this is a medium, and large. Now what I'm supposed to do is use these numbers down here. So that means 7 goes here. Okay, so that's what this is talking about. That's a 7 matching up with this. I like to just write in the words. So next I have with and without. So this is without. This is with whipped cream. This is with whipped cream. Without whipped cream. With, without. So again, I can just go back. Without whipped cream, that's a 2. With whipped cream, boy, they're making it difficult on us, 5. With whipped cream is a 2. And without whipped cream is a 5. Okay? They want it. What's going to happen is on the computer, if you were doing this by computer, you would type in these numbers for those places instead of all the words. Okay, now on this, we can either have it with or without peppermint. So this is with, this is without. I'm going to tell you a little shortcut. Without can also be W/O. That means without peppermint. This is without peppermint. This is with, because we already have. This is with peppermint. Okay, so then we just go back and put the numbers in. Without peppermint is 6. Any place that I have without, I'm going to put a 6. Any place that's with peppermint is a 3. This is a 3 and a 3. Okay, but the main thing is I want you to see how you would make that little table. And if they would ask you how many combinations, how many different ways could I have it, you count this last row. That's what's so beautiful about it. I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could have 12 different ways that I could have that hot chocolate if these were my choices. Okay, Hector has, oh, read this one, get some ideas, pause it. Okay, so hopefully you start marking up 3/4 of an hour. So if I take 3/4 of 60, I'm going to multiply 3/4 times 60. And a lot of you probably just figure out, oh yeah, that's 45 minutes. So that's our total time. It says 1/3 of his time. So 1/3 of, no, we're going to take 1/3 times 45. That's how much is going to be on my math homework. Okay, so 1/3 of 45. And I get 15 minutes. It already tells us how much we're doing for reading. That's 10 minutes. Now science gets the rest of it. So what I do is I find out how much I've used so far. I've used 25 minutes. I have a total of 45. So to find science, I'm going to take 45 minus 25, which means that I have 20 minutes for science. Gary has a box of pencils. In the box, there are 7/21. What you want to do on this one is write everything in lowest terms. So 7/21. Those are both divisible by 7. So I get 1/3. Then come over here and put everything over here in lowest terms. Lowest terms, lowest terms. This one in lowest terms, 12 divided by 4 is just 3, or 3/1. Here, I can divide both of these by a 13, so I get 1/3. Here, I can divide both of these by a 7, and I get 2/6. Oh, wait, I can divide them further. Divide it further by 2. I always forget that 14 goes in 42. But that's the beauty of fractions. If you don't get it the first time, get it the second time. Just make sure when you're done it's in lowest terms. 21 divided by 7, that's 3 again. So now that we've reduced it, all we have to do is see which ones match this. Well, obviously this does. This one does. We reduce it down. And this one does. But see, if I reduce them all down to the same thing, take the original, reduce it down to lowest terms. Good. Read it. Pause it. Ready? Go. So 25% off. When I have 25% off, that means that I'm going to pay 75%. Remember, when I'm dealing in decimals, it's going to be 0.75, and I'm going to take that times the amount of X. Ta-da! B. Last one. Which situation, sorry about that, applies in an additive inverse? Additive inverse, remember, I'm going to be the same number, but opposite signs. So one is positive, one is negative. Okay, that's an additive inverse. So he spent 5, that's a -5. Found 5, so that's a +5. Well, I think we have our answer. Let's double check. Found 5, so +5. Found 5 more, +5. Those aren't additive inverse. They have the same sign. Spent 5, -5. Gave 3 to a friend. Not the same number. Out. Found 5. Kept the money in his pocket. We didn't do anything with it, so 0. So, yep, we were right the first time. Good. And we made it under 30 minutes. So, hopefully that's helpful. And go through this so you can be ready for that map test so you can do your best. Great. Thanks.